Hi, my name is Andy Everton and I head up the expert support team at C2B2. This is going to be the third in a series of webinars looking at Glassfish 4, and today I'm going to be looking at operational monitoring of Glassfish 4. So things we're going to be looking at today. Today's webinar is going to be an introduction to the following areas. This is a large complex subject, and whilst we can't cover everything in one short webinar, hopefully we can give you an overview of some of the areas and show you some useful tools and tips and techniques. I'm going to start off looking at performance tuning. So we're looking here at setting up your system for moving into production. We're going to look at monitoring, where I look at some of the tools that we use for monitoring the system, both during performance testing and tuning, and once that system's up and running. And finally, we're going to take a look at troubleshooting, because no matter what you do, when it comes to performance tuning and monitoring, there's always going to be problems. And so we're going to look at some of the tools you can use to diagnose and detect what went wrong when something happens. Okay, so first of all, we're going to look at performance tuning. So why do we need to performance tune? Well, Glassfish out of the box, as with most app servers, is optimized for development purposes. Developers want the ability to be able to do things quickly, to deploy and deploy continuously, create and remove resources, etc., do debugging. And that's all fine when you're a developer and you're working on a development system, but this configuration is just not suitable for a production system. When configuring any application server, you've got to take into account what you're trying to achieve and what's best suited for the applications you intend to run. And one size does not, unfortunately, fit all. It can be a long and complex process, and unfortunately I can't give you a one-stop solution. There is no optimal solution. However, I can give you some pointers to some of the things you can do in order to prepare your system for production. So what are we looking at to tune? Here are some of the main things we need to look at. We look at tuning the Java virtual machine itself. We're going to take a look at garbage collection. We're going to look at specific Glassfish settings, and we're also going to take a brief look at logging. So JVM settings. Most app servers are set up with the -client option as a JVM setting. Now, although the server and client VMs are very similar, the server one's been specially tuned to maximize peak operating speed, and it's intended for executing long-running server applications which need the fastest possible operating speed, more than stuff like a fast startup time or smaller than time memory footprint. So this is quite an easy setting that we can add, which will give us optimized performance for that server. We also need to look at setting the initial and minimum heap. So the initial stroke minimum heap and the maximum heap, we'll need to set these to the same value. How much you set these to depends on the size and complexity of your application, and also on how much memory you have available. So in order to set these values, we can set these two flags, XMX and XMS. We set these both to the same value. We set the minimum value so that it allocates all of that RAM on startup, so we don't have to waste time doing that later. We also want to look at setting the min-max permgen sizes to the same value. In order to do so, we can use the perm size and the max perm size flags, and this allows you to avoid things like allocation failures and subsequent full garbage collection, which we really want to avoid. So looking at garbage collection, these are a few of the flags that we generally have set, and these can prove extremely useful in diagnosing issues. First of all, we have verbose GC. This enables the logging of garbage collection information, which is not set by default. You can pass it a path to a particular file, so that all garbage collection and logging goes to this particular file, and that's very useful for diagnostic purposes. And then we've got 3 flags at the bottom here, print GC details and GC timestamps. This gives us more detailed information regarding garbage collection and what occurred. And also one at the bottom here, this basically stops developers from using system.gc, which will enforce garbage collection. Hopefully your developers aren't doing this anyway, but if they do, you need to be looking into why. Doing this is generally a very bad idea since it forces major garbage collections. So the best thing to do, set this flag, and then even if they're using it, it won't be enabled. Okay, so next up we can take a quick look at heap dumps. It can often be really difficult to diagnose and discover the causes of out-of-memory errors. And these 2 flags tell the VM to generate a heap dump when an allocation from the Java heap or the permanent generation can't be satisfied. There's no overheading running with this option, so it's very useful in a production system where something like an out-of-memory error could take a long time to come about. So basically we tell it to, on an out-of-memory error, to perform a heap dump, and we give it a path to the file we want it to produce when it creates that heap dump. Okay, so that's just a few of the JVM settings. There's a hell of a lot more, but those are some of the major ones that we look at when we look at a customer system, or when we look at, say, one of our own systems. So next up we're going to look at configuring Glassfish itself and how we go about setting some of these things. So first of all, we can do it through the admin console. We can also do it through editing the individual config files, and we can also do it using the ASAdmin tool from the command line. We'd recommend where possible that you script all changes, so you've got a repeatable production server build. You don't really want to be changing things through the admin console and then having no way of knowing exactly what was done. And even if you do things that way, you certainly want to ensure that all config files are kept in config control so that you know you've got a working copy. So you know you can recreate your production system if necessary with the same settings. So a few Glassfish settings that we'd recommend. We recommend turning off auto deploy and dynamic application reloading. Both of these are great for development, but they can have nasty side effects in terms of performance on your system. And we'd also recommend altering the JSP servlet. Basically you want to set it so that it doesn't check JSP files for changes on every request. That's setting development to false, because again that can be very useful in a development environment, but you don't want that on your production system. And you also want all your string values set to be declared as static character arrays. One of the main reasons for this is that the array will use a lot less memory overhead than a string, and this is a simple setting that you can set in the JSP servlet. A couple of other settings. Accept threads are used to accept new connections to the server and also to schedule existing connections when a new request comes in. These should be set to a number equal to the number of cores in your server. So if you've got 2 CPUs, the quad core, then you need to set this to 8. And also request processing threads, these than HTTP requests. And basically here you're trying to find the optimum number, so you want just enough that you're keeping the machine busy, but not so many that they're competing for CPU resources. Because if they do, then your throughput will suffer. So basically we recommend here just start with a particular number of threads, same as you have CPUs, and then increase them until you no longer see any improvement. So this is a case of testing, then going back and changing the values, and then trying different values to see what the optimum are. Some additional Glassfish settings. We recommend that you use cache static resources like images or CSS files. By default, Glassfish doesn't tell the client to cache static resources. So we recommend setting it so that it does. Also set your thread pool sizes, specifying the same value for the minimum and maximum threads. Allows Glassfish to use a slightly optimized thread pool. Basically here you're looking at sorry, 1 second, I lost my thread. Oh, I'm sorry, wrong. Okay, so basically you want to look at incrementally increasing the thread count and then monitoring the performance. And when that performance stops improving, when you keep increasing it, then you've set your value basically. So adjust your thread count based on the load and the length of time for your average requests. So in general, you want to increase this if you've got idle CPU time and pending requests, and then look at decreasing it if the CPU becomes overloaded. When it comes to logging, obviously when you're looking at debugging and when you're testing and doing that kind of thing, you want as much logging on as possible because you want to see exactly what's happening. But you don't want this in your production system. Ideally, you don't want to be logging anything above warnings or errors in your production environment. You don't want anything really more than that because it's most likely going to result in a massive CPU overhead under the heavy load. And this goes for both logging from your own applications and from Glassfish itself. Okay, so moving on from performance tuning, we're going to look briefly now at monitoring. So this is once your system's set up, how do you go about setting up monitoring to find out what's going on under the covers. Now in Glassfish, all monitoring is disabled by default. Yeah, I can just show you that. So if we look here, I've got Glassfish running in a virtual machine, and we've here got the Glassfish console, which you can get for that localhost 4848. And if we look under configurations in the left-hand panel, and we look under monitoring, we'll see here that all monitoring is switched off, and each of these can be set to low or high or off as they are by default. We'd advise setting at least the JVM to be monitored. That's something that's particularly useful. Now what is also useful is you can switch these on when you're diagnosing issues. They're also useful when doing initial system testing and performance tuning, because you can change things and then monitor what's changed. Let's come back to the beginning. Apologies. Okay. So we're going to look now at some of the things you want to look at monitoring. So first up we have used heap size. So what you want to be doing here is comparing this number with the maximum allowed heap size to see what portion of the heap is being used. So if the used value starts to near the max heap value, then the garbage collector will attempt to free memory, and you don't generally want the garbage collector running too often. So if your used heap size is close to your max heap size, then you need to investigate. You can also look at the number of loaded classes. This is useful for detecting performance and application development trends. Take a look at the JVM threads. This is important for performance tuning and also for troubleshooting JVM crashes. And here you're looking at the current active JVM thread count and the peak values. And also thread pools. So these are groups of reusable threads for serving incoming tasks. So again, here you want to be comparing the current usage values with the maximum allowed to help you troubleshoot any performance issues and application failures. And again, as I mentioned earlier, problems will start here when the current count starts nearing the max number of threads. Okay, so I'm quickly going to go through a few of the JVM tools that we use for monitoring. Starting with JStat. This provides you with memory statistics, details on things like the permanent generation, new generation, old generation, and it also gives you class loading and compilation statistics. We also use JMap. This provides memory usage information. It can provide a class histogram or memory dump to a file, which can be particularly useful. All of these tools come with the JVM, and one of the particularly useful ones is JConsole or JVisualVM. They're both very similar, do very similar things, but basically all the stuff we've previously mentioned that you need to be monitoring and looking at, this will allow you to do that, but it'll also allow you to graph them over time, and this will allow you to follow any trends and get a picture of the performance of your system as a whole. But please note, JConsole and JVisualVM, they really shouldn't be left running permanently on a production system. It's fine to use them in order to diagnose issues, but they're not to be used as a general monitoring tool. Okay, so that's looked at monitoring. Now we're going to move on to, so once you've got your server set up, you're monitoring your server, everything seems to be fine, and then all of a sudden your server crashes. What do you go about doing? Well, first of all, don't panic. That's generally people's reaction, particularly on a production server. It's understandable, and we do understand that, but basically you need to decide what you're going to do. So the first thing you need to do is start looking at gathering data. Get as much data as you can. There's no such thing as having too much data. We'll look at some of the ways you can get your hands on that data in a couple of slides. You then need to look at analysing that data. All that data is useless unless you know what it means. Visualize where possible. As I said, you've got tools like JConsole and VisualVM will allow you to create graphs and charts which will reveal trends and patterns over time. And finally, once you've gathered your data and you've analysed it, hopefully you'll be able to make some educated decisions based on that data, rather than going with things like gut instinct or whatever feels right. Going with that will generally only make things worse. You're better off taking the data, doing a thorough analysis of it, and then making an educated decision based on that data. So how do you go about gathering data? Well, first of all, you want to know where your server is. So you can use the JPS command. This will show you the running Java processes. You can also pass in the -v flag, and that'll give you verbose output, and that'll give you details on all the JVM parameters and things like that that have been passed into the Java process. You can also do PS with the AUX as options, and this will show up these processes from all users. But that generally gives you a lot of information, but you can pipe that through grep in order to see your particular Glassfish process. And we also use top and htop quite a lot. This shows you all your processes and how much memory and CPU they're using. It can be very useful to spot potential out of memory errors or high CPU usage. And htop is basically kind of top on steroids. It's useful taking some time out to learn the htop commands or the top commands. Htop is very useful because you can filter to show only certain processes, e.g. all your Java processes. And basically, once you've got this information, so once you've got the process ID of your particular server, then you can start to get specific information about the JVM. So I mentioned briefly earlier JStat. This outputs statistics about various aspects of the JVM. There's also JStack, and this will allow you to do thread stack dumps for all threads in the JVM, which can be really useful. JMap, as I mentioned earlier, allows you to create heap dumps, and also allows you to output to a file, which a lot of the analysis tools can read. And then two at the bottom here, these are only available if you use the JRocket JDK. The ones above aren't available in the JRocket JDK, but there are different commands which will allow you to do the same things. Now we have another webinar available on JRCMD and JRMC, JRocket Mission Control. And these are very powerful tools, and there's quite a lot to them. So if you are interested in that, then look up our other webinar on that. Glassfish has a built-in tool for providing similar functionality natively. The advantage here is that you don't need the process ID, but this would allow you to generate reports about the JVM through the ASAdmin command line. As I say here, preparation is everything, as I mentioned earlier. We've already covered briefly the command line options for creating or gathering garbage collection information. Basically, for any critical environment, you should be planning for failure. But kind of how can you plan for troubleshooting? Well, these are some useful options that you can add, which will make life easier when things do go wrong. And one particularly useful thing that we found was ASAdmin has a create JVM options command, and that can be used to set any of these values at runtime, so you won't have to restart your server. But this can be very useful if you find issues arising and you don't want to do a restart of your production server, but you want to try and find out what's going on. So this can be useful for setting those at runtime. So once you've gone about gathering your data, you need to look at analysing it. Now, there's some very useful tools out there for doing so. One of these is the IBM Support Assistant, which you can get for Eclipse. This has a garbage collection and memory visualizer, which will produce dynamic graphs showing garbage collections over time, and also produce reports telling you where issues might exist. And it also has a heap analyzer. This is a really powerful tool. Allows you to show the heap as a pie chart divided by the largest classes, which can be very useful. And there's a lot of other functionality in there too, like histograms and the ability to drill down to the precise object which might be causing a memory leak. Mentioned briefly earlier, JVM Emission Control. This is a really powerful tool which you can use to monitor live systems or analyze historical data. So you can make a recording of your data over a period of time and then play it back for the emission control. Again, as I mentioned earlier, we have a previous webinar regarding JVM emission control, so I'm not going to go into detail on that here. We also have JVM. I mentioned this briefly earlier, but also it comes with an optional plugin. JVM is very good for live monitoring, but using the GC Viewer plugin, it can transform that to allow you to analyze data. We also have JHAT, which is the Java Heap Analysis tool. There's better analysis tools out there, but if you've just got the JDK, then this it does the job. Processes heap dump files and allows you to produce HTML reports. And there are many other freely available open source tools and projects. Here we've just covered some of the common and widely used ones, but there are plenty more out there. Okay, so we've come to the end of this webinar. Basically, to go through the conclusions, remember Glassfish out of the box, or out of the zip file, is not designed to be run as it is. You also need to take into account the fact that there's no ideal configuration for all applications or for all systems, and it will take a lot of time and effort to get the best configuration of what you require. I can't specify enough how important performance testing and tuning are. You should be testing again, making changes, and ensuring that your configuration matches the requirements with regards to the application you'll be running. And you should tune your JVM to ensure you have the best settings for your particular configuration. And once it's all in place, make sure you monitor your service performance, particularly once you've gone live. You should ensure that you have enough monitoring in place to keep a check on everything, but also to ensure that you have enough information so that if anything goes wrong, you've got as much information as possible at hand in order to diagnose what caused it. Okay, so that's the end of today's webinar. I hope that was useful for you. We have another one next week. It's the last in the series. And next week we're looking at migrating to Glassfish. Okay, thanks very much and goodbye.